Hello and good morning, everybody. My name is Yiğit Boyar. I'm a member of the UI Toolkit team in Android. But today we'll talk about Android architecture and mostly about next billion users. That's what MBU stands for. Clicker. So, what happens when you develop an application is usually you live in the United States or you live in these developed parts of the world, and this is your main user base. Internet is good or reliable, everything, all the new stuff comes up there. And then you're like, oh, I'm doing my job very well. My application works very well. I'm a good developer. But that's not actually true. Most of the world cannot use your application, or they don't have a good experience. And I say most of the world, it's 78% of the world population. It's this huge. 4 out of 5 people cannot have a good experience with your application. Why? Because what you live, the circumstances you test your application is so different than what they actually observe. So today we'll try to talk about how do we close this gap? What are the things that we should pay attention to make this a lot better? So this is from the International Telecommunication Union numbers. In year 2000, most of the world was in the developed country, 75% of internet users from developed countries. There was only 25% from these developing countries, and they were not buying in-app purchases or whatever. You would mostly ignore them. Well, there was, I guess, no in-app purchase in the year 2000. But you got the point. But in year 2015, there are 3.2 billion internet users, and most of them are in these developing countries. So if you ignore these people, you're actually ignoring the huge chunk of user base. You're ignoring your future. If you want to be successful, your application needs to work very well for these users. It's very important. It's a feature. And you may think this is another number. Is how many people have broadband subscription. In developed countries, it's 90%. Almost all of us have internet connection on our phones if you are living in one of these countries. But if you go into developing countries, it's 40% of people, half of the people don't have mobile broadband subscription. And even if they do, most of these people keep it off. If you've been to India and other parts of the world, people are very, very careful about their data. And only 40% has it anyways. But you might think about, hey, the mobile internet is fast, right? When they want to use my application, it will still work very well. Now let's look at some other numbers to prove this. So overall in the world, the 3G coverage by population is 69%. That's a very good number. 70% of the world population has 3G coverage in their area. That's very good internet by many means. But if you look at the rural population, it's 30%. So if you're not living in a city, there's a 30% chance that your area has 3G coverage. And what's below 3G? We're talking about edge. I don't know. So if you look at urban population, so if you live in a city, there's 90%. It's a very good number. 90% of people have 3G at a given time. So I was talking about these numbers before, and in a conference, I asked people, when was the last time you have seen Edge on your phone, right? You don't do that. You never get it. And as someone replied me on Twitter, you asked me last time I had Edge, it's here in DroidCon San Francisco. So even if you're in San Francisco, that's sometimes what you get. It happens because it's very hard to have a good coverage for populated areas, and then it doesn't end up working well. So how do we fix this? Cache, right? Everybody does this. So you use whatever networking library, it caches your data, you cache your images, you are good, right? No. So we'll look at an example about that. Let's say I have this application that is showing the news from Sharks, the Bay Area team. So I click on the news, I read the news, it's all looking fine, wow. And then I see this. How does this happen? Because I did go somewhere else, I use my phone, I'm out of network, I come back to that page, the activity was killed, restarted. Hey, you never fetched that page because you only fetched the list of news, but you never fetched that particular news page because you did not cache it properly. You show a loading bar to the user. Although you have the data, you have a HTTP cache that has that news item, but you cannot show it to the user. That's very sad. That should not happen. So learn is request caching is not enough. If you're caching, you should be caching your data. So then we say, OK, hopefully we're a little bit agree on we should embrace the next billion users. And how do we do that? This is always the question that comes up. I always put this slide, which architecture I choose. Every other day, there's a new architecture article on the internet. It's crazy, like everybody implements something new, this architecture, that architecture. I have no idea which one to choose. But the actual thing is, it doesn't matter. Who cares which architecture you use? Like your user doesn't care. It's good for you, you should. It's good for you to scale your application, have it stable, test it well. But your users have no idea what you are using. All they care about is their user experience. So this is what should be on your mind every time you write some code. So what to do? There's two main things you need to do. First, your application should work offline. Think about you're writing an app for a desktop 10 years, 15 years ago where there was like usual no network. Think when you're writing an app, plan everything that way. So your application should always work offline, should never require network. And you optimize for the bad network, because even if you have network, it's not necessarily a good network. I know on your desk, in your office, is usually a good network, but that's not what your users have. So you need to think about them. OK. So let's start with offline applications. So what do I mean by offline apps? The major thing you need to be careful about is removing network from your user experience. So when user is interacting with your application, hopefully there should never ever be a network request in that flow. Well, if you are doing a login page, yes, but that's only like a few times it's mandatory, usually it's optional. So let's look at an app. There's a dating app, so there's a guy, and then you click on the like button, because you want to like that, and you are seeing a model dialog, liking Joe. I told you to like Joe, I know, yes, you'll do that. Why do you have to block me for that? Like, don't do that. This is so unnecessary. User doesn't need to know about that. OK. So we say, remove that. Like, don't block the user about this. And if you very briefly, like very abstract level, if you look at the application, what happens there is you click on the button, it calls your like presenter view controller, whatever you choose to use. And then it calls the network. When the network decides to come back, you get rid of the model dialog. But like, who cares? User doesn't even understand. Like, my mom doesn't really understand that there's a network request somewhere. Like, she doesn't know what network is. Get rid of it. So instead, do something, a model, like model your data locally so that when user hits the click button, you just update the model. Your mark it as liked. They say, like, 100 milliseconds, 200 milliseconds, it comes back, you update the view. Then your model tells it to the network, hey, like there's a change I have locally, can you apply it to the server? And the server comes back, you refresh your view again because now you really change it. So if we implemented it this way, it will look like this. You tap on the button. There's some sort of indication that user receives a feedback instantly. And then when you finally synchronize it, it turns red. So it's important that you give a feedback to the user so they understand something has changed. And then you finally also let them know. And the users learn this, and this is what we call a responsive user experience. So we'll look at the same application again. I tap on it. Oh, it's yellow, nice. I know something is happening. It received my tap. So I go back. There's other people. You tap someone else again. You go here, nice. It's still doing something, like it's consistent. This is good. Then I go to, OK, I did that again, another use case. And I go to this page, like I'm just reading news, right? I stay there, I do something else. And Android decides to kill the application because we needed memory. And time passes, I come back to the application, and bang. I don't see it anymore. That was yellow. I put some information like this is so annoying for the user. You put some comment, you come back, it's not there anymore. Now you have no idea what happened there. Like, did it post? Did it not post? What happened? Is a buggy app? So you don't want to do this. And how do we fix this? So in the previous one where we said the view controller calls the model calls the network, blah, blah. OK, let's improve this a little bit. Introduce something, call it application logic, and make the model persistent. is very important. Like you should definitely use SQLite, use Realm, use whatever you want. We don't care, but use persistent data storage. So when the application logic does any network request, it always updates the persistent model, and then dispatches an event, or you might be using RxJava observables. Again, we don't care. Dispatches an event, and the view shows the state on the model. There are two important parts here. The model should be persistent, and the view should always reflect what is in the model. So you don't just go and change the button to like selected state while you try to make a web request. Don't do that. Update the model, let the view refresh itself. Because when you do this, as a user click, you tell the application logic, I want to send a like. That updates the model. Model says, hey, I have changed. Or the application logic says, I have changed. And your view knows, if user is there, are like, all right, I should refresh myself because the data I'm displaying has changed. So you go there, it refreshes the URL. This is when it is yellow because you know data is pending, it's not synced yet. And now when the application logic finally syncs it, maybe 3 days later, who cares? It updates the model again, and if your view is still there, it's going to refresh itself. The idea is you write these views, they try to represent what's in the model and nothing else. Of course, some like transient temporary UI states. So we look at the application again, we go there was a profile you see, you go back, you go to another profile, you go back. Like you're using the application for a while. And now what happens is, you go back to this list again, and there's a loading. It's like, I was on the application 2 minutes ago, I saw that list. Like there is no way you are loading that list because I know the list is there. So what went wrong here? So it's what was happening. Every time you go into a UI, you fetch the list of users, right? You fetch the data, if the user liked it. So this is your like background thread pool. You keep consuming these things. You have multiple workers. So one of them is refreshing user data from network. The other one is, again, like doing stuff, sends the user stats. And like you went back to that UI, you want to read the list of users from the disk, so you implement the right way. You are trying to load it from the disk. But the problem is, your background threads are busy trying to make a network request. Like this is so bad because you know disk is there, you know you will be able to access it. But the network you don't know. And you are making the user wait for no reason. And the solution for this is very simple. You just have different queues. For different type of events, have different queues. Well, you cannot just create a queue for every type of event, but usually, at least, you should have one for your network-related stuff and one for your local access. Even for local access, you'll probably just use a loader or an async task. That will be fast enough because those things are like under 200 milliseconds, 300 milliseconds, very fast. So once we do this, as we add these tasks because we want to get data, they get consumed in different queues. So even if the network is slow, locally everything is working. This is what we call like application should work offline. Like everything just works. And then you're trying to sync it later on. Of course, it's not always everything, whatever. So we look at the other section. How do we optimize for the next billion? And the next billion looks like this. So this is 101. You need to translate your application. If you want people to use it in other areas of the world, you want it to be translated. So you translate the application, you translate your assets because you may have text there, and you also translate your in-app purchases so that they can spend money. But actually, this is not completely true. Translating is not enough. That's not the right word. The right thing you should do is localize. So localize your application. Don't just translate it because let's say you have an application about a family, like communicating with their kids, whatever. On the Play Store page, if you have an American family in the United States, put an Indonesian family in Indonesia. And if you're in China, put a Chinese family. Like you should localize your assets also within the application because that's what will make sense to that user. Every culture has their differences. And if you want to make best of localization, this is what you should be doing. And the other thing is text-free layouts. Now, when you can do this, it's really useful. For example, if you have a messaging app, if you just want to say send, don't say send, put a checkbox. WhatsApp does this very well. Or if it is red, put double checkbox. This helps you first. You don't need to translate it. It's fairly global. Your users learn it, and even if if your application is not messaging something else, the literature rate may not be very good in that area. This will help more users be able to use your application. Another example: if you don't have Wi-Fi, don't say no Wi-Fi. Just put this. They learn. People learn these things, and multiple applications use the same icons. And if you use like the material team and stuff, when user lands in your application, they actually know it. Like they get a head start. This is very important. The other thing is about adaptive content fetching. So let's say this is an application that shows photos, and this is the same UI. Pretty much looks the same. Of course, the one on the right is kind of low quality, but the one on the left is 100% JPEG, and the right is 10% JPEG. It's almost 1/10 of it in terms of size, and it looks okay. Now, of course, you don't want to show a lower quality image to your users, but you need to think about they either see the lower quality image or they see a blank screen. There's a big difference between seeing a blank screen and a low quality image. And bonus points, you can refetch the content. So you realize the network is not very good, you fetch the lower quality image. And once you figure out somewhere else the network recovers, you refetch those images. Especially if it is free, you should do that. And luckily now the Connectivity Manager API actually tells you if the network is metered or not. So I want to give some examples what we do at Google about these things. For example, if you're using Google+, in the settings menu, there's a way to say, OK, commerce data usage. Now, like, if you're even living in the United States, you probably don't really check because you have unlimited data. But the rest of the people pay premiums for their data. So they're very, very conscious about it. So you put the settings like that. And in Google+, these are what we actually do. If the network is fast, we fetch a high-quality JPEG. As the network goes slower, we go lower on WebP versions. So we show a version. At least, like, instead of seeing a blank screen, user sees some data. We help them save their data. This is a win-win. And they get a better user experience. And we also educate the users. This is also important. And it's like, what does it mean, the commerce data? Why don't you always do it, right? Like, why are you wasting my data? And then if users click on there, we explain them, this is what it means to save data. Another part is adaptive behavior. Now, it's very common in applications to have like auto-playing GIFs or auto-playing videos. What you should do is, at this point when user is showing my feed, is the network fast? If the network is fast, it's cool, just go auto-play the video. But if the network is slow, don't do that. Just put a play button. Don't waste their network just because they may want to watch that video. That's a bad thing for your users. And I have good network here, so I will play this video. Yes. Good girl. Applause for Frida. OK, so for example, this is what we do on YouTube, right? In YouTube, if you go to quality settings, there's an option that says auto. It's actually what it does. By checking the network quality, we adjust your bitrate. And I'm sure you are so used to this behavior, you maybe don't even notice. But it takes time to implement. But the good news is, the Exo Player library from Google already supports Dash and smooth streaming. All you have to do is use this library and let it handle these different network protocols. Of course, also your server side needs to support it. But it's not hard, it's easy, it's important. OK. Come on. All right. So this is another use case. We'll look at Uncle Bob. So this guy goes to work every morning, takes the bus, maybe Google bus, reads his news on the bus, does the same thing on the way back. This happens all the time. But what also happens all the time is this. He's seeing a loading dialog when he tries to read his network, read his news, because there's like another 60 people in the same bus trying to use the same internet connection, and there's a lot of other cars there. It's where like the network gets congested, and he cannot get, like, no one gets a good experience. How can we fix this? Well, good news is that this guy goes to work almost the same time every morning. So he wakes up at 6:30. No-brainer, set an alarm, right? We can set an alarm to prepare the content for him. And also maybe he leaves the work at like 5:30 every night. Then we set an alarm for that and prepare the content. so that they get some content when they open the application. And the way we can do this is we have the Alarm Manager class that will help you wake up your application every morning 6:30 so you can prefetch your content. So let's say we implemented it, we are good, right? So all these users have a good experience every morning 6:30, they get the latest news and they are happy. But then we get more users, and more users make this request like 6:30, and then this is what happens. Your cloud goes down. And you know what comes up when your cloud goes down? Your system admin. That guy slept at like 4:30 a.m. in the morning. You woke him up at 6:30 with a pager. Why? Because you just made that request at 6:30 from every single client. And actually, it's a real story. We once received a bug request from a provider. They said there's a bug with Android phones. Every morning at this time, we are getting so many requests. Turns out it was an application like this. So we don't do that. How do we fix this? Super simple. So instead of just waking up at 6:30, you randomize it. Wake up between 6 and 7, and then you wake up each application in that random time. And then your server admin is happy. But then we are unhappy. Using Alarm Manager seriously? 2016. Come on, how do we do this? We do this with JobScheduler. Or you can use GCM Network Manager for the older API versions. So we wanted to do this with JobScheduler. You create a job, you say, OK, this is my service. You say, we want the unmetered network. There is no reason to cache the data if the user is going to pay for it. And then we say, OK, start the earliest around 6:30, and then make it only if the device is idle. And you say, if it's only charging. Like, these are all optional things. You say, all right, deadline. These are all optional things that you can do depending on your use case. So what does this override deadline mean? So the idea here is that, let's say we have this thing and user forgot to charge their phone. So we will never wake up in the morning, but what will happen is the job will be just waiting there, sitting idle. Maybe user will go to work, and then they will plug their phone, and then we will fetch the content. It's already passed, like we missed the deadline. Why would you do this? So we tell the job scheduler, hey, if you cannot do this until 7:30, wake me up. So what we can do is, when the job is started, you can simply check, OK, did I get the deadline? Did the deadline expire? If the deadline expired, if that's why I was woken up, this is all custom logic, where you say, OK, is the connection unlimited? If it is not, just return false. I don't want to run this job anymore. Or if you can say something like, if the battery is charging or is like at least 75%, otherwise, I will not run this job. So this completely depends on your use case, but you get the idea. Like, try to be thoughtful about these things. I think we provide enough many APIs on the framework side to be able to implement these things. And it's not hard. And at the end, your user receives a really, really good user experience. It's important. So for example, in YouTube, you can go ahead and download a video for offline. So that, like, you do it at home, you watch the TV series, you download it, and while on the bus, you can watch it. Or in maps, like recently, I was on vacation outside the country, and I just downloaded the area on Google Maps. And even though I didn't have data there, I could use my phone to navigate. It was so nice. So these are like little things that makes a huge user experience difference. Or for example, another example of prefetching. This is slightly different, but this is what we do in Google+. So we have, whenever we detect that there are new posts, we show a like little touch button that you can tap to refresh. So in there, what happens behind the scenes is we detect there are new posts, we let the user know, and if the user taps, we are going to go ahead and fetch the content and then refresh the UI. Now we changed this a little bit. This is what we did. When we detect new posts now, we actually go ahead and fetch it because users in the application, we detected new posts, like they want to see it, right? We are like fairly comfortable that they want that content. So we fetch it for them. And then we let the user know that there is new content. Look, we don't just refresh it because they might be doing something else and it will be a really bad user experience. Instead, we just notify the user there is new content. And if they tap, we will refresh the data. Now, the difference between these two user experience flows is the first one takes around 3 seconds, the second one takes 0.3 seconds. This is like almost 10x. There's a 9x difference. You just change the order of two operations. A huge user experience improvement with very, very little effort is important. But if you're doing prefetching, it's a very dangerous thing. It's really good for users, but it might be also really bad. So you need to be careful. First thing you should be doing is balance for the available storage. That just don't fill out their phone, especially in the rest of the world. Like the phones have lower memory, so you shouldn't be filling it out with your prefetch content. Or if you are going to fetch some data that's expensive, let the user know. Like, I want to do this update. Provide them settings for these things. Like these people are really, really they care about their data. They're really, really into it. So you should give them options, and they will use them. The other part is, so now I always get this thing like, oh, now the Android devices have 2-3 gigabytes of memory. We don't need to care about it. Wrong. It's not like that, because first, the screens got a lot bigger, so we need to use a lot more graphic memory. Your assets get a lot more higher quality. Those things are wasting a lot more memory than they used to do before. Plus, we try to run a lot more many applications, because that's the best for the user. So always measure your memory. And like in the latest versions of Android Studio, this is so easy. You just tap on a button. I remember before, you will need to use get the memory down from DDMS, and then HProf convert it, and then open it in Eclipse Math. That was a mess. Now in Android Studio, you just click on a button, takes the heap dump for you, it opens this in this nice UI, and there's usual suspects there. So you just click on that, we will show you all instances of it. You can check, okay, why am I retaining this object? And the coolest thing, I love this thing, you can just right-click on the selected item, view bitmap. Like, how cool is that? You know what you have leaked. This is so much faster than what you were able to do before. So we're always spending time on making these tools better, and you should take advantage of them. So also in AND, so you guys have seen in Marshmallow, in AND, we are spending a lot of time in battery life. This is very important for us, overall system health, and we cannot do this without your help. So in AND, we also introduced this new feature called Data Saver, where user can say, you know what, I want to limit the application data for the background apps. They don't get any data unless the network is limited. But if you're a good application, user might whitelist you. So if you implement it properly, they will whitelist you. So you will get the data while your competitor doesn't. And it only works in metered networks, so we only block you if we have a reason to do so. So how you use it? So the connectivity manager now has this new API. We could say, hey, is the active network metered? And if it is metered, you can get the background status, if it is enabled, or if you are whitelisted, or you are disabled. So the idea is that even if user put data saver on, but you are whitelisted, you should still be cautious about, okay, I don't want to spend too much data. Hey, I have user status data. Just postpone it. You can send it later. You don't need to send it now. Okay. So we'll go into some more offline use cases. And I want you to start thinking about, okay, how can I make my application more offline? So it's one use case. The first time we gave this talk a year ago, people say, okay, if I have a commercial app, right? There's a place where people buy products. I cannot make it offline, which is true. You cannot make it offline because the price changes. There's no way you'll tell them, hey, you bought this for $500, and then one day later you charge them $700. You cannot do that. That would be rude. But there's still things you can do. In your application, product information, right? When you buy something, when I'm going to buy something, mostly like electronic, I go to the same page again and again and again. This will happen. This is user behavior. So optimize for that. Keep the user data. Let them search. I will probably search for the same products. Let them do a local search. Remember when we talk about having a proper persistent model? It helps you here because you can let them search locally, but still let them know that I'm showing the local results only. If they go to the product page, show some sort of animation saying that you cannot buy this right now, I'm fetching the price, your designer will give you a better asset, and then when the price comes, you show it to them. So you don't block the user But for important data, you just don't show it. Or show it grayed out, I don't know. But think about this. Another example is a messaging gap. So let's say Jenny and Michael. So there's a couple. Jenny says, okay, let's go to a movie. Michael says, sure, let's watch The Big Short. Jenny says, fine, pick me up at 7. And then, okay, we'll meet at 7. But around 6:30, Michael realized that, hey, like his dog is sick. He doesn't want to leave the dog home. So he says, hey, Jenny, like my dog is sick. Well, how about you come over? We hang out at home. That's all cool. Unless, well, the message couldn't be sent for whatever reason. Failed, tap to try again. So as a developer, I let the user know I'm done. You're actually not done. Because Michael, he wants to call his vet to get some tips and stuff, so he already left the application. So Michael did not know that you couldn't send the message. When Michael couldn't know that you didn't send the message, Jenny never saw the message, and this is Jenny's heart. It's broken because of you. You sure? Okay, no. All right, we have a solution. What could you do? You can do something better, right? It's important. You don't need to, if you like the dating profile and you couldn't send it to the user now, it's fine. It's not that important. There's a messaging application. It's an instant messaging application. You have some responsibilities. So if you couldn't send the message, and user didn't see it, let them know. Show a notification. Because you already know that user is not in your activity. You already know that they did not see the message. So instead, you show a notification, Michael calls his girlfriend, and they're a happy couple, thanks to you. And another thing too, that you can further improve the user experiences, you can always let them know. If you're in the screen, they're messaging, if you know there's no internet connection, just put it. By the way, if you're listening for internet connection in AND or O, well, you only receive that broadcast if you are the front application. Don't register for that broadcast in your manifest. It will actually stop working. So, you can try. It's not going to work. But in your application, you can still use the connectivity manager and register that broadcast programmatically. So as another example, if you have TV schedule application, of course, they cannot watch TV offline. But you can do some stuff. You can let them click on a button and schedule an alarm, right? This is there's still things they can do because you can implement all of this within the device without requiring any network communication. So the idea here is that if you start thinking about what can I do offline, you will find really, really good use cases, and it's going to differentiate your application. So even though when we talk about this talk, we say it's next billion users offline, this actually helps your users everywhere around the world. It's not only for them. Okay. So I want to quickly go through this. It's okay, I'll say you synchronize the data, right? You update the persistent model, and then you synchronize data. How do you do this? So luckily, scientists has been working on this problem. We don't have to solve it. There's something called operational transform, where things like Google Docs uses. Or there's conflict-free replication. And there's a bunch of things I don't know. There's a lot of articles, but you don't need them. What we apply is the Pareto principle. We will do the 20% of the work, we'll get the 80% of the benefits, and we will run away. For example, if you have a post or a user, that's something you can like. And when user likes it, you mark it as liked, you update the model. But what happens is next time, there was another request running, and it fetches the list of posts again, it just overrides what you have put there. That's a bad problem. How do you solve this? Very easy. You add another field that you only modify locally, so it's yours. I call this local here. So when you want to check if user liked the post, all you do is, hey, you update that field. When you fetch the feed, it doesn't override because that field doesn't exist on the server side. And if you want to get, when you are putting the UI, if you want to check, did the user like this? Well, it's very simple. You check if there's a local value, show it. Otherwise, use the value that you last received from the server. And this is very, very simple thing, super easy to implement, and gives you most of the benefit. Excuse me. So another example, let's say you were fetching posts, some posts have been deleted on the server. Tell your server guys, let them send you the list of deleted posts. It's so easy for them to do. And this way, you can locally cache everything, always show everything locally, and if something has been deleted on the server, you will eventually get notified about it, and you will update your local data. This is very easy for them to do. So if we get another example, you could be sending the server, hey, I have the post between 8 and 31 when you make a call to get the new posts. You always send a scene state or whatever, right? And now the server can again send you which items from that range has been deleted. I know it's sometimes hard to convince your backend people, there's a clash, everybody wants the other people to do the work. And there's this thing hey, I have a perfect REST API, so you make 25 requests just to fetch a feed. Don't let them do that. Don't let them do that. Fight for it. It's important that they provide you the right APIs for your application. So there's another case here, I'm trying to update the profile page. I have two different clients. One of them changes the favorite color, the other one changes the name, and I get a conflict. How do you solve this kind of conflicts? Add a version. Now, your data is versioned. So when you make a request, client says, OK, change the favorite color to this one on top of version 10. And then the server can say, OK, since this version, I can apply this diff and do it. Or decide whatever you want to do. Maybe you don't want them to do that. The thing is, it will happen very, very rarely, and you will be handling that case. So things won't override each other. And if you start versioning your objects, your value objects, you get this nice thing where, hey, you made a request to fetch posts. Some of them were updated. Server already knows. You told the server, I have these items with these versions. The stuff that has been changed, they can tell you, hey, these are the posts that have been updated, and here's their new data. In one request, you get all of the diff. Again, I'm not telling you to do things this way. This is just a way of doing things. It's very simple, and it's effective. OK. So if you want to read more about this topic, you can go learn about multi-version concurrency control. It's widely used in databases. Maybe some really, really important, learn about operational transform if it's really, really important for you to multiple clients changing the same data. So these are solved problems. You just need to go and check them. So that's not hard. OK, I will go through some quickly tips and tricks. It's little bite-sized information. As I said before, when we talk about network, design your API for your client. So again, back to that thing, I have a perfect REST API. No, that doesn't matter. But the perfect API is the one that my user experience fits the best. This is what you want. So do it. Tell them to do it for you. I don't know. But your API should be for your application. And whatever you can do on the server, do it on the server. If they can pass metadata, anything that will help you, do it there. Because it's much easier to scale than the tiny device you have on your pocket. And one more thing you do is batch your requests. Now, again and again, we say battery life is very important. Data is very important. If you batch your requests, the battery life will improve a lot. JobScheduler already does it for you. So, just use JobScheduler or GCM Network Manager. You'll be a good citizen. We will love you. It's good things. So, for example, this is an example of a bad API. This is a terrible API. It gives me a user as a name and a photo URL. I have no idea what that photo URL represents. You put in a staggered grid in recycle view. When you fetch the photo, grid starts moving because you don't know how big the image is. You just put something random there, and the image turned out to be a really weird one. So your UI had to reschedule. It's terrible for the user. It's very, very easy to fix. Tell your server to send you the width and height of the image, so you can put a placeholder. Anything in recycle view loves this. When they call onBind, they want to have the final size. If your server sends it to you, you have the final size. You can even send the palette. It's also very easy to calculate on the server side instead of doing it on the device. They send you the palette of the picture. So while you are fetching the picture, instead of just showing a gray box, you show another box that has the same background color, so you can easily transform to the new one. This improves user experience. Is very important. So to sum up everything, the main goal here is you architecture your application for the user experience. They can be in the United States, they can be Indonesia, China, doesn't matter. The important thing is their user experience. It's your responsibility. Have a real local model. Just don't keep things in hash maps. put them onto disk, SQLite, use Realm, whatever you prefer. We don't care, but put it on disk. And when you write your application, don't think, like, OK, now I get this data from the server, and I update this UI, and user click on this, I make this other request. Don't do that. Think about, I have the data on the disk. That's what I show to the user. When user reacts, I have some logic to update the data on the disk, and I show it all the time. And you have some other application logic that tries to synchronize the data with the server. It makes it a lot easier. And decouple. Like this is, like, you should decouple these things. The part that's related to the UI and the disk, they know each other. You have an application logic that talks to the network. When you decouple things, it makes it a lot easier to test. But don't overdo it. Like when I see there's more popular architectures and stuff, and people, hey, I create an interface, and the interface for the factories, and the interface of the factories. It's like, don't do that. This is still a phone. If you look at the framework code, we still write it as we write C. You don't have to write it like that. Use enums, whatever, do it. Use it if it makes your application better. But don't over-architect. It's still a mobile phone. We are trying to run many applications on the same device. And even if the device have 4 cores, 8 cores, most of the time only 1 or 2 of those cores are actually really capable of doing anything. Plus, we try to keep them low mode or not run them at all to save battery. And act early. This is important. In a previous job I worked, I paid this debt. If you have this kind of technical debt, it's really, really hard to pay. So the sooner you start, the better it is. And one last note, something to remember from this talk, know your enemies. Network is unreliable. You don't want to be doing a network request. Every time you make a network request, you should feel uncomfortable. Oh, what's going on? And then know your friends. Disk is your friend. Persist everything. It's very reliable. If the disk is broken, the phone is already broken, so you don't need to worry about it. So, is your friend is actually your best friend. Thank you.